Unit 6, Rational Functions by Sua, Luis, and Margarita. We will be using the 5 quick checks that were available to us and use those practice problems as a way to describe and solve rational functions.
Let's take a look at some variation problems. To start off, let's remember some stuff. For a direct variation, when you graph an equation, it is usually linear. And as we remember, or we don't, linear graph looks like this. And the form for it is y equals mx plus b. Now, you may wonder, why do we need to know this for direct variation? Well, direct variation comes from linear equations. So b is 0 in direct variations, meaning we do not need b. And then m becomes k. So the form for direct variation is y equals kx. For those problems that we are going to do, we need to suppose that x and y vary directly. So, vary directly. And directly means multiply. Multiply. So, let's start. Problem 1. Y is 4, x is -2. What I like to do is always bring the original form into the area that we're working, because it helps us keep everything together and just plug the problem in better. So let's write it down, y equals kx, and start the problem. Y is 4. We don't know k, so let's leave that blank. X is -2, and then k. From here, we just solve for k, just like any other equation. Okay, this is what we found. If you want to check whether your solution is correct or not, plug it back into the original equation, which is this. You should know that by now. So y equals kx, y is 4, k is -2. We just found that. And x is -2. As we know, negative times negative is positive. 2 times 2 is 4, so that'll be +4. And that's correct. No, the answer would be y equals -2x. Let's do another problem to let everything sink in. Okay. Y is 7, x is 2. Again, let's take this and put it into the workspace and do the same thing we just did. So y is 7, x is 2, and k is just k. Divide it. And because we can't go any further than this, we would just put 7/2 as k. And let's check it real quick. Y equals kx. 7 is 7/2. Let's put imaginary 1 over here. 7 times 2 is 14. 2 times 1 is 2. Divide that, 7. 7 is 7. And we just solved the problem. Yep, there we go. And that's how you do it. Graphs of rational functions. This is the example we will work with. And before I start, I want to say that you cannot have a cube when you are doing the box method, because you need to factor both of these, the top and the bottom. Now we can factor. this is where we shift to the boxing method. This number goes over here, and then this one here. I meant variable. Now, to find these, we need to use the x, and the top would be a times c, which are these two, which are this one is a, and then this would automatically be bb, and this one is c, and that applies to the bottom one as well. So we multiply them, negative 8x squared and 2x. And we need to, those numbers are supposed to be numbers that when you multiply them, they are equal to this, but when you add them, they are this. So 4x, negative 2x. That works the best. Then put those into the box, and then find the outside. And I found this because when you multiply these, you get this. Multiply these, you get this, and then the same thing here. Put that on the top. X plus 4, x minus 2. Now we move to the bottom one. The same thing, you plug in everything you know. And then this one, multiply these, and then this one is a standalone. Negative. This one would not be negative. Sorry, that was supposed to be positive. 2x. These numbers would be 3x and negative 1x because it wouldn't be the other way. You couldn't put negative 3 but positive 1 because that would mean that the 2x would be negative. So it wouldn't work. This is the best one. Then we put those in the box. We would get this. And now we're going to the final steps. Before I go any further, I want to mention that discontinuities are the numbers that x cannot be. And we are trying to find the discontinuities. So you need to be careful when you do this. To find discontinuities, we need to cancel out those numbers. So positive 3. What would cancel out positive 3? Negative 3. So negative 3 plus 3. Then simplify. That's 0. Then the same thing with negative 1. The opposite would be positive 1. No, it would be negative 1 because negative plus negative is positive. So our discontinuities would be negative 3 and 1.
Quick check 3, simplifying rational functions. I will be using problems 1 and 2 from the practice problems. So for number 1, it's 40m to the power of 6 divided by 50m cubed. So first we have to take out the constants, and that will give us 40 over 50 times 6m to the power of 6 over m cubed. Then we just simplify the 40 over 50 to 4 over 5 and keep the same m to the power of 6 over m over 3. Then we can use the quotient rule to make it into 4m to the power of 6 minus 3 divided by 5. Then we just simplify that power to 3. So we get 4m to the power of 3 over 5. And that is the final expression. We have the second problem, which is 40n divided by 90n to the power of 4. So first, like we did with the first question, we take out the constants, which would give us 40 over 90 times n over n to the power of 4. We can simplify that 40 over 90 to 4 over 9. Then we use the quotient rule again, which will give us 4n to the power of 1 minus 4 divided by 9. We can simplify that 1 minus 4 to a negative 3, which will give us 4n to the power of negative 3 over 9. Then we can use the negative rule power, and we will get 4 times 1 divided by n to the power of 3 over 9. We can simplify that 4 times 1 divided by n to the power of 3 to 4 divided by n to the power of 3, and then simplify that even further into the final expression, which is 4 divided by 9n cubed. Then we have the second problem, which is 40n divided by 90n to the power of 4. So first, like we did with the first question, we take out the constants, which would give us 40 over 90 times n over n to the power of 4. We can simplify that 40 over 90 to 4 over 9. Then we use the quotient rule again, which will give us 4n to the power of 1 minus 4 divided by 9. We can simplify that 1 minus 4 to a negative 3, which will give us 4n to the power of negative 3 over 9. Then we can use the negative rule power, and we will get 4 times 1 divided by n to the power of 3 over 9. We can simplify that 4 times 1 divided by n to the power of 3 to 4 divided by n to the power of 3, and then simplify that even further into the final expression, which is 4 divided by 9n cubed. Quick check for operations with rational expressions. So I will be using questions 1 and 2. For the first question, it's m plus 3n divided by 6n minus 3m plus n divided by 6n. So first, to solve this expression, we have to join the denominators together, which will give us m plus 3n minus parentheses 3m plus n divided by 6n. Then we can remove the parentheses and collect the like terms. That will give us parentheses m minus 3m plus parentheses 3n minus n over 6n. We can further simplify the m minus 3m plus parentheses 3n minus n to negative 2m plus 2n over 6n. Then we can factor out the common term of 2, which will give us negative 2 parentheses m minus n divided by 6n. We can move the negative sign to the left and then simplify that further. Simplify the 2m minus n over 6 to m minus n over 3n. And then that will be our final problem, which is negative n minus n over 3n. For the second rational expression, it is a bit longer. So first we have to cancel out the y from the whole expression. Then we can simplify the 5 over 15x to the power of 3 to 1 over 3x cubed. Then we rewrite the expression with the common denominator found in both of these expressions and then regroup the terms. Then we can factor out the common term of 3 and collect the like terms together. Then we can simplify the parentheses 5y minus 4y parentheses plus x to y plus x. Simplify the 3x cubed plus or times 15y to 45x cubed y. Then we just simplify it and we get y plus x divided by 15x cubed y, which is the final answer.
Alright, quick check 5, solving rational equations. For these type of equations, what you want to do first is find the lowest common denominator, which in this case will be 3x parentheses x minus 8. So first, we cancel the 3 pieces of the equation out. We end up getting this equation right here. Our next step is to distribute the 3 and x minus 8 and the x and x minus 8. We end up getting this equation right here. Our next step is going to be using the box method to get to this part of the equation. in the end, you end up getting two factors of -12 and -2. What you do then is you set them both to 0 to get x equals 12 or x equals 2. Thank you for watching our Algebra 2 podcast.